Hello everyone, welcome back to my channel. I've come with a new video which is about data structures and applications. Let's see what we'll do in this video. I first welcome everyone to my channel. So we'll be discussing about pointers in C in this video. Let's start with the definition of pointers. Pointer in C is a variable that holds the memory address of another variable. It provides a way to indirectly access the value of a variable using its address. Let's see the declaration and initialization. To declare a pointer, we use this asterisk symbol you see here before the name of the pointer variable. For example, here PTR is a variable and we use the asterisk. So it declares a pointer to an integer. We have given the data type int, so it is an integer. To initialize this pointer, we assign that pointer the address of a variable. So we'll take int x is equals to 10. Here x is a variable and it has the value 10. Int pointer is equals to ampersand x. By writing this sentence, we initialize the pointer with the address of x. Let's see the characteristics of pointers. Pointers are special variables that store the memory address instead of value like usual variables. Usual variables store the values, but here pointers store the address of another variable which has a value. Pointers always hold addresses as a whole number. Pointers in C are always initialized null. It is necessary to remember this. Null pointer symbol is 0 because it is null. There is nothing inside. The asterisk symbol is used to retrieve the value of the variable. And ampersand symbol is used to retrieve address of the variable. Let's see the uses in what situations or how do we use this ampersand and asterisk operator. First, we'll start with ampersand operator. It is used for getting the address of the variable. If you use ampersand before a variable name, it returns the address of that variable. For example, there's here ampersand y. Ampersand y, if you use that, it will return the address of the variable y. Here is a small program, hash include stdio.h, hash include conio.h. In main, in this main function, there is an integer y, and we printf percentage %p, comma ampersand y. This prints the address of the variable y, return 0. This is a small program. Now let's see about the asterisk operator. There are two operations that can be performed through this asterisk symbol. First one is declaration. This asterisk symbol is used to declare a pointer variable. For example, int asterisk ptr. It declares a pointer to an integer, the data type int. Now the next is dereferencing. The asterisk is also used for dereferencing a pointer, which means accessing the value stored at a memory location pointed to by the pointer. Here's a small program which shows about dereferencing. There's a variable int x is equals to 10 and the pointer is initialized with the address of x. Int ampersand ptr is equals to int asterisk ptr is equals to ampersand x. Now next, what we do is dereferencing this pointer to access the value at the address it points to. So int value is equals to asterisk ptr. So the value will be 10 because the variable has 10 and we dereference it, so the value comes back. Value is equals to 10. Let's see what null pointers are. Null pointer is a pointer that does not point to any memory location. It's a good practice to initialize pointers to null to avoid pointing to invalid memory. It is better to show 0 than showing an error. Here's an example of pointer, like example for pointer variable. Hash include stdio.h. Int main, we declare a variable, number is equals to 10. And then we declare a pointer and assign the address of the variable, which is int asterisk ptr is equals to ampersand num. Next, we access that value using pointer. Print a value of the number, percentage %d, comma, asterisk pointer. Now we modify that value using pointer. We change the value, asterisk ptr is equals to 20. And then we check whether the value has been changed or not. Printf, modified value of num, percentage %d, comma, number, return 0. And you'll get the output as 20. Let's see what double pointers are. A double pointer in C is a pointer that points to another pointer. First, we saw about pointer. Pointer was what? It was a variable which stored the address of another variable. But here double pointer is a pointer which stores the address of a pointer. And pointer, it stores the address of a variable. Double pointers are also known as pointers to pointers. They are often used in situations where you need to dynamically allocate memory for a pointer and modify the original pointer through the second level of indirection. Let's see an example of double point. Include stdio.h, int main. The value is 42. Next, we declare a pointer 1 to an integer and is equals to ampersand value. Then next, we declare another pointer 2, and we store the address of pointer 1 in that. Next, we access the value using double pointer. Printf, value using double pointer, percentage %d, ampersand pointer 2. Because here we are accessing value using double pointer. So it is pointer 2. Next, we modify the value using double pointer. So we'll initialize it. The value of pointer 2 is equals to 92. And we check whether it has been modified or not. Printf modified value percentage %d, value, return 0. This is the end of the program for double pointer. Well, let's see what are the uses of pointers. We learned what are pointers, double pointers, but we should also know like where to use them. Not just learning that, we have to get to know the real life uses of pointers so that we can understand in clear, more detail. Dynamic memory allocation. What is dynamic memory allocation? Dynamic memory allocation is something like it. We don't allocate the memory in the starting itself. Like we allocate the memory after while execution is occurring. So by doing this, we save space, which is a very important thing because in starting, you'll just be given like 2 bytes for each variable, and then you don't store enough information and a lot of space is left out, which is a wastage of space. To avoid that, dynamic memory allocation is followed, and to do dynamic memory allocation, we use pointers. And then swapping values. There is 2 variables x and y, and you swap the values. Like x's value will be in y and y's value will be in x. That is swapping values. And next, array manipulation. To manipulate an array, pointers are used. And the same way, string manipulation. To manipulate a string, pointers are used. Then function parameter modification. Every function has parameters, and to modify those parameters, pointers are used. These are some basic real life uses, applications of pointers. And that's the end of my video. Thank you for listening. Please do like, share, and subscribe if you liked it. Thank you.